Okay, so a lot of you have expressed concerns that you're having trouble graphing these exponential functions. So you've been having trouble using the Mylab to graph these exponential functions. So I decided to make this video to help out how to graph these functions. And so we have we have this question here, which is f of x is equal to 2 power x, and we have h of x is equal to 2 power x plus 2 minus 1. But to graph these functions, we have to first learn how to do it by hand, and that will help us when we try to use this MATLAB graphing utility to graph this. So first, let's look at how we can graph this by hand. So let me share the screen of how we can of how we are going to draw this by hand. And so I have my blackboard here. So we have f of x is equal to 2x, and h of x is equal to 2 power x plus 1. h of x h of x is also equal to 2 power x plus 1. And x plus 1, no, x plus 2 rather, and minus 1. So we have x plus 2, let me write this again, 2 power x plus 2 and minus 1. All right, so the immediate observation between of the difference between h of x and f of x is that h of x, first of all, has horizontally been shifted. So it's a horizontal shift to the left by 2 units. Horizontal shift to the left by 2 units. So that is why we have power x plus 2. It means horizontally shifted to the left by 2 units. And the minus 1 signifies that it's been shifted downwards, vertical shift. Or let me write, it's a vertical shift downwards by 1. Vertical shift downwards by 1. All right, so before we get to graphing h of x, let's first try to graph f of x. So to graph f of x, we pick values between x values between -2 and +2. And we find the corresponding f of x values. So this is 2 power -2, which is 1/4. This is 2 power -1, which is 1/2. 2 power 0, which is 1. This is 2 power 1, which is 2. 2 power 2, which is 4. All right, so we can graph f of x now. So f of x, we have x coordinates from -1, -2, -3, -4. We have on the positive side, we have 1, 2, 3, 4, and we have 1, 2, 3, 4 on the y-axis, and this is the x, and we have -1, -2, -3, -4 here. All right, and so the first pair of points when x is -2, y is -1/4. So that is about this point here. When x is -1, y is -1/2. It's about this point. When x is 0, y is 1, which is this point. When x is 1, y is 2, just about this point. When x is 2, y is 4, just about this point. So we can draw a line through these points, and that will be our f of x. And if you can see from how this graph looks, as we keep moving away further in the x-axis, we keep moving left to the x-axis. You can see that the function f of x is getting closer and closer to the x-axis. So we call this behavior the asymptote. The asymptote is when the values of f of x keep getting keep getting smaller and smaller, or moving to the left, like moving to the left more and more. The f of x graph will get closer and closer to the x-axis. Uh, Although it will never touch it, but it will get close and close to it. So we call this the asymptotic behavior. And this line on the x-axis, which I've indicated by dashes, is the line y is equal to 0. So we call this line y is equal to 0 the asymptote. All right, so this is how we graph f of x. So let's move on and draw and try to graph h of x. So h of x is equal to 2x plus 2, 2 power x plus 2, and minus 1. 2 power x plus 2 minus 1. So um, before we graph it also, we have to also pick x values and calculate the corresponding values. But what we have to note here in the h of x values is that because of the power x plus 2, h of x has been shifted to the right, has been shifted to the left by 2. Because of this power x plus 2 here, h of x has been shifted to the left by 2. So what that means is that we will have to get the x values for h of x. We'll have to subtract 2 from the f of x values. So you remember the f of x was from negative 2 to positive 2. So for h of x, negative 2 becomes negative 2 minus 2. So that is negative 4. And negative 1 becomes negative 1 minus 2. So that becomes negative 3. And the 0 becomes 0 minus 2. So that is negative 2. And the 1 becomes 1 minus 2. That gives us negative 1. And the last point, which is 2, becomes 2 minus 2, which is 0. So for h of x, instead of negative 2, negative 1, 0, 1, 2, we subtract 2 from each of these x values. And so we get negative 4, negative 3, negative 2, negative 1, and 0. So now we can find the corresponding h of x values. And so the h of x values, h of x is equal to 2 power x plus 2 minus 1. All right, so now when x is negative 4, we have 2 power negative 4 plus 2 minus 1. And so this equals to 2 power negative 2 minus 1. And so this is 2 power negative 2 is 1/4. So we have 1/4 minus 1, which equals to negative 0.75. We have 2 power negative 3 plus 2 minus 1, which equals 2 power negative 1 minus 1. So this is 1/2 minus 1, which is negative 0.5. And the next is we have 2 power negative 2 plus 2 minus 1. So this is 2 power 0 minus 1. So this is 1 minus 1. which equals to 0. We have 2 power negative 1, 2 power 2 power negative 1 plus 2 minus 1. So this equals to 2 power negative 2 power negative 1. Let me check this. So 2 power negative 3 plus 2 was 2 power negative 1. And now we have negative x, which is negative 1. So negative 1 plus 2 becomes 2 power positive 2. Right. So this becomes 2 power, this was 2 power 0 minus 1, which is 1 minus 1, which gives us 0. And this is 2 power positive 1. This is 2 power negative 1 plus 2 is positive 1. So 2 power positive 1 minus 1. So this is 2 minus 1, which gives us 1. And the last one is 2 power 0 plus 2 minus 1. So this is 2 squared minus 1. And 2 squared is 4. So this becomes 4 minus 1, which is 3. So these are the points we get for these are the points we get for uh, these are the points we get for the h of x. So now let's graph it by hand. Then we'll move on to Mylab to also graph it, to try to graph it using the Mylab utility. All right, so let me graph this here. So x goes from, we have 0, -1, -2, -3, and -4. And we have here 1, 2, 3, 4. And on the y-axis, we have 1, 2, 3, 4. And we have here -1, -2, -3, and -4. All right, so the first pair of points is -4 and -0.75. So that is about here. We use green for these points. -4, -0.75 is about here. The next is -3 and 0.5 is about here. And the next one is -2 and 0 is about this point. And the -2 and 0 is about this point. The next one is -1 and +1. So -1, +1 is about this point. And the last one is 0. This one is -1 and +1. No, I think that's a mistake in this point. This is 1. Uh, when x is -1 and y is +1, it's about this point here. And when x is 0 and y is 3, it's about here. All right, so we have these points that we can draw a line through to get our graph, so we get this. So this is our h of x, and you can see that as it gets closer and closer to -1, as it gets closer and closer to -1, it begins to flatten out. So we say that this is the asymptote. So as it gets closer and closer to -3, it begins to flatten out, but it will never cross -1, but it begins to flatten out. So the line y is equal to -1 is the asymptote. y is equal to -1 is the asymptote. So now that we have these points and we know how to graph it by hand, we can now try to do this by, we can also now try to graph this on Mylab itself. So let's switch to Mylab. Let's switch the screen to Mylab. Let's switch the screen to Mylab. So on Mylab, so we have this. So h of x is 2x plus 2 power x plus 2 minus 1, 2 power x plus 2 and minus 1. All right, we want to graph this, right? And so the first thing that we do is we click this enlarge graph. And when we go to the enlarge graph, the first thing that we do is to draw the asymptote line. The asymptote line, like we found out earlier, was the line y equals to -1, right? So we want to draw the asymptote line. So we click on line and we click on this dashed line, and the line it should be y is equal to -1 is this point. So we click on -1, x is 0, -1 on the y-axis, and we click another point on the same line again, such as this. Let's see. It's a bit tricky. No, let me clear this. Let me clear this and do it again. Let me cancel. Let me clear this and do it again. So the first thing is we want to draw the asymptote, and the asymptote for h of x is the line y is equal to -1. So we click on this line, which is the solid line. We want to draw a line, but we want the asymptote to be a dash one. So we click on that on this dash, and we try to click on 2 points. No, there's no way I want to point. And another point. No, no. Let me see. No, no, there's not that point. Let me clear. Uh-huh. Let me clear. Let me try once more. It's a bit tricky. So let me click on point 1 and another point. I want to click another point. Another point. No, another point. It's just no, 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 no. Yeah, let me try to use edit coordinates. So the points I want are let me try to delete this 4. Uh, so I want the points when x is 0 and y is 1. So I want 0 and y is -1. Um, y is -1. So -1. Uh, and I need to click submit. And the other line is here, either here. Yeah, you can click anywhere on that same straight line as this. And so I want a straight line. X is 3. So I want to draw a straight line through y is equal to -1. So I can click on 2 points along the line y is equal to -1. So this and this, so I need these 2 points and I need to join them by a straight line. So this is the line, but I need to clean this line here. This other vertical line is not needed. I want to clear it. Okay, so let's clear all objects and let's try again. It's a little bit tricky. So I click on this line. Let me click on what? No, I need 0, -1. And let's see another point. I want to click on another point. This is tricky. Let me clear again. Let me clear again. I need to clear again and let me click on this. I want to click on, let me edit coordinates now. I want to edit, let me edit the coordinates. Uh, This is 0. This is 0. I want to submit. So this is the first point, and I need another point on y is equal to -1 again. So let me click here. Oh, no, I don't need this line. All right, let me first, let me clear this again. It looks like I'm having some trouble. Let me make it bigger. Okay, so I want to draw, I want to click on this point. I think the key was I have to expand it so it becomes bigger because I'm using a touch screen. I have to expand it to make it bigger. All right, so I want to draw uh, a dashed line through this. So this is what I want. So this is the asymptote. So this is a dashed line through y is equal to -1. So the asymptote is the first thing that we draw. So I have this line. So the next one I want to draw is the curve itself, right? And so the curve itself, I will click on this solid line. I'll click on the solid line for the exponential function and I'll type like anything here, right? And I get this. All right. So once I get this is not the graph that I want, right? So now I'll use this utility here to shift the graph to the points that I want to. So horizontally, this graph has been shifted to the left by 2. So if we look at horizontal translation, we will scroll down to the left by 2. So we scroll down to the left, -1, -2. It's been shifted to the left by 2. So I scroll horizontally to the left by 2 by using this scrolling utility here. And vertically, it's been shifted down by 1. So I also will scroll vertically to move the coordinate to -1. So this is 1, this is -1. All right, so this is -1. So now this is the function that I want. By using the horizontal translation and the vertical translation, I have been able to draw my line now. So you see that the asymptote is the blue line, and the yellow line, it needs to be solid. Let me see how I can change it to be solid. It needs to be solid. It needs to be solid. Let me see. It needs to be a solid line, not a dotted line. So uh, let me, okay, let me clear. I want to make sure that, okay, let me clear and do this again, because I need the exponential one to be a solid line, not a dotted line. So let me see if I can click and delete. Uh, Let me click on this. Let me click on this too. Let me click on this too and delete. Let me click on this too and delete because I need a solid line. I need a solid line. No. Okay, let me draw the exponential one again. I need it to be a solid line, not not a dash line. So I click on solid and I click on the exponential and I click on any point here. Yeah, so this is, I want it to be a solid line. So this is what I want. And now I need to do the transformations. So h of x has been shifted to the left by 2. So horizontal translation, I scroll to -2. And it's also been shifted vertically downwards by 1. So vertical translation, I scroll to -1. And the base is 2 as specified. So now I click save here. So this is now the function that I want. Um, this is the function that I want. And let's see whether it's correct. So let's see. So let's go to submit check answer. So if you go to check answer, we see that it is correct. Okay. And now we can go to, it says find the asymptote. So the asymptote is the line y is equal to -1. So the asymptote is y is equal to -1. Um, so the asymptote is the line y is equal to -1. Um, all right, so it says that is correct. And the domain of this graph is also from -infinity to positive infinity, right? So the domain is -infinity to to the domain of this graph is from -infinity to positive infinity. So let's put uh, our parenthesis here. Um, all right, so because I'm using a touch screen, I'm having trouble typing. But the main thing I wanted to illustrate is plotting this function, and this is how we plot it. All right, so thank you very much, and I'll see you.